Hi everyone, this is the third video in our journey fixing 5 non-working motherboards from eBay. I'll drop a link on the screen for those who haven't seen the first video yet, so you can catch up on how this all started. Today, we're tracking 2 boards at once, one from MSI, one from ASUS. 2 different manufacturers, 2 different fault stories, and honestly, no idea yet what we're walking into. That's the whole point of those no-return eBay listings. Sellers dump them because they're dead, nobody wants to hassle of diagnosing them, and that's exactly where we come in. Let's see what's hiding inside this time. Hang on, it's about to get interesting. Another board from the batch. eBay is hidden gem for mystery electronics. You never know what you get when you buy stuff listed for parts. This one is the MSI B550 Tomahawk, but the listing title actually said Tomahawk Max Wi-Fi. So literally we get a different board, a cheaper one. I won't complain tough since both boards were sold for parts at the same price, still the impression is a bit off. Not exactly what we paid for, but let's see what's actually wrong with it before we judge the deal. Okay, so let's measure the resistances. So 3.2 volts, and we have almost a kilo ohm, 5 volts, kilo ohms, 5 VSB, 3 kilo ohms, 12 volts, kilo ohms as well, minus 12. Here we have no short, and 12 volt CPU. Here we have 15 kilo ohms. Then we need 12 volts to V core, mega ohms, no short. Now we have a lot of coils open on this board, and what we would like to check is this is probably 2.5 volts. The memory, 1.3 kilo ohm. This one, 1.8 volts, I guess. Kilo ohms as well. Coil over here. That's 3 kilo ohms. We have a coil right here. This is our 5 volts. Even mega ohms here. And here's another one. There's a 12 over 5. Hello. Do we have a contact? Yeah, it's kilo ohms as well. No short. Okay, so I guess we can try to power it on. So the seller note is it's tested and does not boot. However, BIOS was updated successfully, and CPU fan spins without the CPU installed. But when CPU is installed, it shows no signs of life. So usually on these boards, when you see this kind of behavior, you should look for a broken trace or a knocked off component. But first, let's power it on real quick, just to confirm we get power without the CPU installed. So now pressing the power button, and we have drastically low consumption. It's only 12, maybe 13 milliamps. This is very, very low. Do we have a reaction on the power button? And we do. So, of course, we have a CPU debug light because there's no CPU. Okay, let's install the CPU. We are going to use today Ryzen 3 Pro 4350G. This is one of our testing CPU for AM4 boards, and we have a stick of DDR4 memory, and so we have A1, A2, B1, B2. So we'll use A2, the first priority, one of the first priorities slots. Now we will power on, and now we have around 100 milliamps, which is healthy and as it should be. Now pressing the power button, and we have no reaction on the power button. Okay, it's interesting. And when I remove the CPU, so I will power on, and now we have power. Okay, I guess what we would need to do is to make a visual inspection and try to find something unusual. We will start with the area where the GPU is mounting. Let's see, the first PCI Express slot. I don't see any signs of damage right here. The PCI Express clip is clean, and the PCB underneath is as well. Looks totally normal. The BIOS chip untouched. The SIO area looks normal. This is our audio codec. It looks normal. Then we'll go through the system fans and LED connectors, USB connectors, USB 3 connectors, so there's no shorted pins on those connectors. What about the memory voltages? So those two coils, they're taking care of the CPU and the memory voltage. Let's go to the back of the board. So the CPU area looks clean. All VRAM capacitors are present. Those are the caps of the PCI Express lines. Okay. Oh, here we go. That's the problem. We have a knocked off resistor right here. This is according to the schematic, this is a pull-up resistor for BDDP VSB enabled. So basically without this resistor, we don't have 1.8 volts for the CPU in the standby mode, which is very important, produced by this chip. So basically, without this resistor, this chip is always disabled. I suspect this is our problem, and it should be an easy fix. Soldering in a new resistor here. Looks like a 401 package. Let's do it and see if this turns out to be an easy peasy repair. Let's power it up. Power on. Whoa, 281 milliamps. Those are a lot. Let's press the power button, and we have a reaction right now. The CPU light is on. Guess I need a heatsink over here. Okay. VGA. And will we have a boot screen? I still have VGA. Oh wait, boot LED. Here we go, it's busted. This is a good example of how one tiny component on the back of the board can stop it from working completely. So we have a fresh stable BIOS released in 2026. I guess the seller had tried to flash the BIOS but couldn't get it to post because of the knocked off resistor. So I'm moving this board to the testing bench, but something is telling me that it's completely working and can serve for no less than it already did. So let's see another motherboard we have for today. Here we go, another motherboard, and this one is a name for like the majority on the channel. This is an ASUS board with an LGA 1200 socket. Ladies and gentlemen, welcome ASUS Prime Z590P. Whatever it means, this board has all aluminum style heatsinks, which look similar to all premium boards, but actually this board came to the market in 2021. So it has 11 DRMOS power stages, PCI Express 4, and 2.5 gigs Ethernet on the board, which is cool. It's definitely useful nowadays. However, this one isn't working. So this board was bought on eBay for $21 as not working, no returns, no refunds, no objections to its state, functionality, or condition. The seller's description is interesting. It says it powers on, but no post, no banned CPU pins, might be a corrupt BIOS. So let's check the resistances on the main power rails. 3.3 volts, and we have 47 ohms. Well, actually, this is a kind of low. 5 volts, 2.4 kilo ohms, 12 volts, kilo ohms, 5 VSB, 5 volts standby. We have kilo ohms as well, minus 12, so mega ohms, no short. Now the CPU 12 volts has mega ohms. Then the 12 volts to VE core. Mega ohms no short to SOC. So we definitely have no short between 12 volts and CPU. That's good. Here are the open coils. I guess all of them are CPU voltage rails. Mega ohms here, mega ohms here, and mega ohms over here. Another coil right here is probably the power of the PCH, and we have mega ohms. Oh no, we have kilo ohms here, and 2.5 volts DDR4 memory, power line 22 kilo ohms, and that's it. So my main concern right now is low resistance on 3.3 volts. It's just 47 ohms, and I want to count on at least a couple hundreds of ohms. 47 ohms may be partial short of some of the power rails connected to this line, but who knows. Since we have an LGA 1200 socket instead of AM4, we need to check the CPU socket pins to rule out bent or broken pins, because even one broken pin could make this board unrepairable. So I see that there is no bent pins. Try to apply a filter, doesn't help. So let's try to power it on. So pressing the button on the power supply, and we have 110 milliamps of consumption, which is actually normal. So then we will press the power button, and okay, we have just 650 milliamps of consumption. It means that the board just partially started, and some of the main power rails are actually not running. And what we need to check is, do we have the voltage of V-core? And we don't. What about these coils? We have nothing over here. Do we have a battery voltage? We do. So this is the second coil. Okay, another side. Okay, we have 0.95 volts on this coil and 1.06 on this coil. So it's minus because I used black probe. And here we go, 106. Yeah. Here should be 5 volts. What about 2.5 volts? And we do have it. What about the PCH power line? 1.8 volts, and we have it. And this is probably 3 VSB line, and we have 3.2 volts. Okay. So far everything looks normal. I guess we need to make a visual inspection to see, do we have any knocked off components or cut traces. Whatever we find abnormal here, we should take a look at this. Let's do it. Okay, so first of all, we don't have any signs of PCI Express latch opening within the screwdriver. So let's start with the SIO area. This I/O chip area looks clean and absolutely normal. Audio codec circuitry has no knocked off components so far. No visible damage in RTC area. This is Realtek Ethernet controller, one of the sensitive areas. It is sometimes physically damaged during GPU mounting. Nothing critical so far. There's the circuitry near CPU socket looks fantastic. Let's move on to the area of standby voltage regulators and VDDQ power rail. VDDQ is represented on this board by 4 low gate and 2 high gate MOSFETs with 1 driver chip. On the back side of the board, we're now in the VRM area with filtering caps for 12 volt supply of VRM power stages. As you can see, they are all in place and no visible damage or broken traces. The back of the CPU has just several caps populated on the board, so the prime board does not look like have prime voltage filtering. Oh wow, look at that. It looks like these capacitor legs are shorted to each other. Let me check. I have never seen this before. How this should work at all? Why these legs extensions were not cut at the manufacturer? I bet they can short 5 VSB or, what is worse, 12 volts to ground, so it could probably result in a nice bright spark, actually. Whatever. I will cut them later, and now we'll just try to make them straight a bit. I cannot find anything critical using the microscope, so we definitely need to remove the heatsinks. And look what we have underneath. PCH looks actually normal. However, we have a and the VRAM as well. Looks normal. Let's measure the resistances on those small capacitors. Those are all the power lines. So we have 50 ohms. Okay. Here we have 50 ohms as well. So this is one line. And we should do this. 50 ohms. The kilo ohms is here. Okay, 115. 115. Kilo ohms, 160 kilo ohms. These small caps here, 160. So it looks to me that the PCH it's alive, and I have no problems with that here. I cannot find the issue, and I guess to be on the safe side, let's flash a new fresh BIOS using programmer and see if it helps. I could make it to flash using TPM header. This motherboard has 2 BIOS chips, one for actual BIOS and another one for Intel ME firmware. So I decided to desolder the chips and reflash them separately by splitting the firmware region in UEFI tool. Let's see if it helped. And what I need to do is to clear RTC as well. The board is powered off. So, power on. Okay, we have 182 milliamps. Now pressing the power button. So this is the case where it's not getting better and getting worse. It looks like I know the problem, and I do not believe that BIOS flashing can prevent the power button to start the board. So here's the conclusion I got within this repair. I only desoldered 2 BIOS chips, flashed them with the firmware, and soldered them back. The BIOS firmware cannot prevent this board from having a reaction on power button. The chips here located near the PCH, which can affect the power button on such early stages of power sequencing. So the only explanation of this behavior can be faulty PCH, which we affected with a hit by hitting BIOS chips nearby. To be 101% sure about it, let's prove this here with the thermal camera. Okay, so here is the thermal camera. And when I point it here and power it on, so you see that the only element is hitting is the chipset itself. So it means that when I did applied hit right near the chipset, right here, the chipset was hit as well. And initial problem was not in firmware inside the BIOS chips, but I think with the high probability in the chipset itself. So the chipset consumes a lot of power right now. It's 180 milliamps, which shouldn't be so, since it's actually doing nothing right now. And there's no reaction on the power button at all. I guess this board will become one of the donor boards I have. Unfortunately, it's not worth to replace PCH on this motherboard model. However, I'm glad that we have made it and repaired 3 motherboards of 5 bought on eBay, and 1 board among them is still waiting for repair actually. This is it for today. I hope it won't be too long since I combined 2 repairs in one video. I want to finish this series since I have new interesting motherboards for repairs related on my bench waiting for our attention. Please do not forget to hit that like and subscribe buttons. You can find the links to equipment I use in the description under my video, and thanks for watching this video, and see you in the next one.